All right, I want to show you about something called factorial in mathematics, and this becomes a very important technique when we're dealing in the area of probability. So by definition, n factorial, or the factorial of any natural number n, is going to be the product of that number and every natural number smaller than that number. So what we mean by that is if I have something like 3 factorial, 3 with this exclamation point afterwards, what we do is we start with 3 and we're going to multiply it by every natural number that comes before it. So 3 times 2 times 1. We wouldn't multiply by 0 or any negatives or anything like that. So 3 times 2 times 1 is 6. If we have something like 4 factorial, then we're going to go 4 times 3 times 2 times 1. So that same 6 times 4 is 24. So what about a number like 1? 1 factorial. Well, we would start with 1 and multiply by every natural number that comes before it. Well, there aren't any. So 1 factorial is going to be 1. We do have a 0 factorial, even though 0 is not a natural number. It's a whole number. It's an integer, but it's not a natural number. So we define 0 factorial to be 1. We're not going to have it be 0 or anything like that. But 0 factorial is not calculated. It's defined to be 1. There is a way to calculate the factorial of a number on your graphing calculator with just a few keystrokes. We can do this by, first of all, hitting the Math button, then going over to Probability along the top, and option number 4 here is the Factorial button. So if we wanted to find the value of, say, 5 factorial, this is exactly how we would type it in. Is first we would type in the 5, then go to the Math button, over to the Probability menu, and down to option number 4 to find the factorial key. After hitting Enter, you should get 120. You could use your graphing calculator to simplify this expression. In fact, if you want to pause the video right now and give it a shot, that's not a bad idea. But if you want to just see what the answer is, it's 6. I want to show you how to do that by hand because it's really not too terribly difficult. See, what we want to do is to look at 6 factorial as its definition, not as what its product is. And by its definition, 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial starts with 5 and 5 times 4 times 3 times 2 times 1. And one thing we know about division is that its inverse is multiplication. So since the only thing we have in numerators and denominators are factors, we can cancel those common factors, starting with the 5 all the way down to the 1, so that the only thing we're left with is that 6. Now, like I said, you can find 6 factorial over 5 factorial using your graphing calculator. But a problem that's pretty much just as easy as that one, your calculator can't do. 100 factorial over 98 factorial. If you were to try that one in your graphing calculator, typing it all in correctly, hitting enter, you immediately get an error. It's an overflow error, and what the details of the error on your calculator tell you is that the numbers that you're trying to come up with are way too big for your calculator to handle them. And when we think about the definition, what factorial is, for 100 factorial, that's going to be 100 times 99 times 98 times 97 times 96 times 95, all the way down until we get to 3 times 2 times 1. And that is going to be an extraordinarily large number. So will 98 factorial. But by its definition, 98 factorial is 98 times 97 times 96 times 95, all the way down to 3 times 2 times 1. And when we start to cancel from here, we recognize that I can start canceling with the 98 and the 97 and keep going all the way down until we get to cancel those 3 times 2 times 1. So the end result after canceling, like we should, is just 100 times 99, or 9,900. Very easy to do by hand, impossible to do on your graphing calculator. I want to try just a couple more examples because fractions that look like this are going to be ones that we're going to encounter a lot when we're dealing with probability. This first one, 9 factorial over the product of 7 factorial and 2 factorial. The way you want to do these is to expand them out, really. To think about 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when it comes to that denominator, we're going to have 7 factorial, or 7, 6, 5, 4, 3, 2, and 1. That's going to be multiplied by 2 factorial, just 2 times 1. Then start to cancel things. In the denominator, we're still multiplying everything together. And what we should recognize is that from 7 all the way down to 1 is going to cancel with that 7 factorial. Now we're left with 9 times 8 divided by 2 times 1. And we can still do some more canceling. This 2 can cancel with that 8 and leave a factor of 4. So the only thing that's left now is the 1 in the denominator, which is awesome, because we're going to go through looking at our numerator. The only things that are left are going to be 9 times 4, which is 36. If we have something like 10 factorial over 5 factorial times 5 factorial, maybe expanding it all the way out is a little excessive. But I could recognize that with 10 factorial, it's 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. Well, all of that is just 5 factorial. Then in my denominator, I recognize that I have the exact same 5 factorial, and then another 5 factorial. Well, for that one, I am going to expand it as to 5 times 4 times 3 times 2 and times 1. And go through and cancel everywhere that I can. That 5 factorial that left, those two are going to cancel with each other. And every factor that's left should have a factor in the numerator that cancels as well. For instance, 3 times 2 here, that is 6. 4 goes into 8 twice, and 5 goes into 10 twice. Now when we look at what we have left, I got 2 2's. 2 times 2 is 4, and 9 times 7 is 63. 4 times 63 is going to be 232. One thing that you should be looking out for when you get to your final answer with all these problems is that your final answer should be a whole number. You shouldn't have any decimals or fractions left over. Everything in the denominator should cancel with something in the numerator.